Okay, hi and welcome. Note 6.4 part 2. I did a little bit of work for us here. I'll talk about that in a second, but let's read question number 5 here. It says, write an equation for the line in example 3. Well, here's the line from example 3. Let me highlight it for you. Possibly. Here's the equation we had left off with in the first part of the notes. We took 2 points from a graph, remember the graph? And we took one of them, which was 0.23, and we wrote it into, after we found slope, point-slope form. And we ended like that. And we said, that's an equation line, we're done. But this particular question is asking us to write that point-slope form, but it wants us to use the other point, the one we hadn't used before. So there's the other point, -1, -5. Make that change. I think it's wrong in your notes. Make sure that's a -5. All right, so now we're going to take this other point, we're going to plug it in, use the same slope because we want it to be that line. We want this to be the equation of that line. And we're going to show you that it doesn't matter which point we use by doing that through changing forms. So that's what I did here. I changed the form of this point slope form, and I did all the work so you can kind of watch it. We're going to do it again here in a second, but I ended up in slope intercept form. Okay, and so what I'm also going to do in this example is I'm going to show you that any point will work with the slope, but I'm also going to show you how to get to slope intercept form. So, are you ready? Let's do it. All right, so we're going to start with that same base equation. Y minus y1 equals slope times the quantity of x minus x1. I highly encourage you to write this each time you use it because it looks awkward, it's kind of funny, and by writing it you'll get used to it and you'll get to kind of familiar with it and it'll become second nature, hopefully. Alright, so now that we've got that part started, we're going to go ahead and label our x1 point and our y1 point just so we're aware of it. We already know our slope. We're going to steal it from over here, 8/3, because we already calculated that in the previous problem. So let's start plugging stuff in. So I'm going to write y minus my y1 coordinate. Now remember, that's a -5, and this is supposed to be a negative, so both together are going to become a positive. I'm just going to go ahead and change it there. Alright, and then I'm going to write my 8/3 slope in, and now I'm going to write x plus, again, here's a negative for the start. Here's a negative right here. There are two negatives make a positive, so I'm going to put +1. Alright, so there's the equation of the line. All done. But it did ask us to put it in slope-intercept form. So we've got to take it another step. Alright, and that would, otherwise we'd be done. So let's go ahead and do that. Now this is the process, and it's been sitting over here. That's what I went through to get to slope-intercept form. We're going to do this one together. So let me change the color on my pen just so we can see it move along. Alright, first step is you want to get this distributed because we've got this 8/3 times both of these quantities. And if you remember, to get in slope-intercept form, our job is to solve for y. Well, I can move this 5 over, but I want it to look like point-slope form. I want to see a clear slope, and I want to see a clear y-intercept. So I need to do this distributive property. So let's write down y plus 5 because nothing happened to them. And then I'm going to go ahead and distribute. 8/3 times x is 8/3 x. And 8/3 times 1 is, well, you guessed it, 8/3. So that was pretty simple so far. So we're really pretty close to being done. The next step that we've got to do is move this 5. So I'll change my color again because I'm into changing colors right now. And I'm going to go ahead and subtract 5. Okay, now this will reduce out and become 0, leaving us just a y. So we're almost in the right form. We just have to clean this side up. So I subtract from the left, I need to subtract from the right. So I'm going to subtract 5. Here's the thing. I'm going to turn that into a fraction. Why, you ask? Because these are the like terms. 8/3 x, or 8/3, not 8/3 x, has to be combined with this -5. And to be able to do that, I need a special term. Anybody in the crowd? Yes, you answered it correctly. Common denominators. You can see that I did that here. Remember, common denominator means that you're multiplying by some form of 1, okay, so that we're not changing the function. So to multiply by form 1 means we have to multiply by the same number over the same number. That's going to allow us to have the denominators be the same. Well, in this case, it's actually not so bad because here's 3 and here's 1. I can make both of them 3 by multiplying -5 over 1 by 3 over 3. 3 over 3 is 1. I'm not changing anything, but this will give me a denominator of 3. So let's do a quick little calculation on the side over here. 8, or let's multiply this out, I guess, first. So we're going to get -5 times 3, which is a -15. And 3 times 1 is 3. So there's my new form of -5 over 1, -15/3. Again, you should be pretty familiar with that. We can now add numerators and have the same denominator. So we're one step away from being done. Really, all we have to do is rewrite. So 8/3 x. There's my slope. And then I've got to take 8 and subtract it from 15. I'm going to get -7. And my denominator is the same. And so I leave it 3. And what you should see right away, and I'm going to highlight it, is that these two equations are the same. Ooh, it turns red. All right, they're the same. Okay, so they may look different from the beginning. So you can see it here and here. They look a little different, but when we solve them both in point slope form, they end up being the same. All right, let's move on and do one more example, and we'll call it a day. Next example is writing it from a table of values. It's really nothing different than we haven't already done. We're not going to write it in slope-intercept form, but here's a table set of values. Remember, if we have a table set of values and it's told us that it's linear, and you can see right there that it says linear, we're going to go ahead and find the change in y over the change in x, also known as rate of change. Okay, so let's do that. I'm going to go ahead and subtract these two. Here's my y2 point, here's my y1, or 6 minus 4 gives me 2. And I'm going to find it over here on this side as well. 3 minus a -1 is 4. Okay, so I can stop there because it did say it's linear. So I've already got the difference of 1y and the difference of x. Didn't matter which points I used as long as I used the same points. Here's one point, right? You can see it. Here's the other point. You can see that. So I just pick any 2 points. Didn't matter which ones I used from the table. I use those first 2 because first 2 are easy. So now I'm going to write the change in y, or the differences in the y, over the change in x. That's going to be my slope. In this case, it's going to be equal to 2 over 4, or 1/2. There's my slope. Guess what? I'm basically done. I'm going to rewrite the basic form of this equation in point slope. So y minus y1 equals slope times x minus x1. And I'm just going to plug in the stuff I know. Here's my slope. Here's some points. Let's use 3 and 6. They're positive. It's easier. Let's do that. Here's my y coordinate. Here's my y1. Here's my x coordinate. Here's my x1. So here we go. Y minus my 6 equals my slope, 1/2, times x minus my x1, which is 3. I'm done. That is how easy it is to write an equation for a line if you have a point and a slope. All right, so down here at the bottom summarizes all 3 forms. Remember, we have to be able to change between these forms. That's huge. Changing forms. Okay? We've talked about it. We did it with literal equations. We see the benefit of moving from one to the other. Hopefully we see the other. We should be able to go between any form. Okay? It doesn't matter which form we start with or which form we end with. We should be able to change between the forms. Again, good for intercepts in standard form. Intercepts. This one's kind of versatile. Good for really slope and y-intercept if we need y-intercept. This one's great for writing equations. Not so bad from graphing from either. U-A-T-I-O-N-S equations. Okay? They each have their own benefit. We need to be able to move between them. And that's the notes. All right, we'll see you in class, guys.